This is the Unit 5 test review. All right, the first thing we want to be able to do is identify each of the following. So here's our polynomial. The degree means the highest exponent. So you look at each of your exponents. We have an exponent of 3 and an exponent of 2. Since 3 is bigger, that's our degree. All right, the coefficients are the numbers attached to the letters. Excuse me. So find each letter and see which number is attached to it. So our coefficients would be 3 for the first one, -7 for the next x, and then a +9 for the last x. All right, and then the constant is the number that's by itself without a letter. So any number that's by itself that doesn't have a letter is a constant. So in this case, it's -11. And then the number of terms. You can determine the number of terms by splitting them up wherever you see a plus or minus sign. So 3x to the third is the first term, and then there's a minus sign. So we know that this is the next term, and we're going to go all the way until we see another plus or minus sign. So right there's a plus sign, so that's another term. We're going to start from this plus sign and go until we see another operation, and there's a minus sign, so that's the next term. And then this is the last term. So in this case, there are 4 terms. All right, we want to simplify the polynomial. So to do this, we're going to have to combine like terms. 4x to the third is the first thing I see, so I'm going to skim and see if there's any other x to the thirds. And there's not, so I'm just going to go ahead and write down 4x to the third. All right, the next thing I see is -x squared. Now, anytime there's not a number there, put a 1. So it's -1x squared, and so I'm going to look for any other x squareds. Here we have a +5x squared, and here we have a +2x squared. So if I combine those, and you definitely don't have to write this out. Usually I just do it in my head or my calculator. But 5 + 2 is 7, and 7 - 1 is 6. So this gives us 6x squared, and since 6 is positive, we're going to put a plus sign. And then we're going to look at the next one. We have a +8, which is just a constant. And so we look for other constants, and we have a -10. So -10 + 8, that would give me a -2. And that is my final answer. I can't simplify it any further. So we want to add or subtract. Now notice we have a minus sign here in the middle, so we have to make sure that we distribute that negative. And when we distribute that negative, what it's going to do is it's going to change the sign. Because here a negative times a negative makes a positive. And here we have a negative times a positive, which makes a negative. So when you see that minus sign, you got to distribute it to everything in the back parentheses, which just basically means change the sign. And then for this first parentheses, I'm just going to write it down. I'm just bringing it straight down without the parentheses. Oh, and right here, since this is a +4, we're going to put a plus in front of it. Sorry. All right, and then we combine like terms. The first thing I see is 7x squared, so I'm looking for other x squareds, and here's an x squared. Remember, whenever you look at these, you always look at the sign in front of it. So 7x squared plus 4x squared is going to be 11x squared. The next thing I see is a +2x, so I'm looking for other x's. There's not anymore, so I'm just going to write down +2x. And then I have a -3 and a -4, so that makes a -7. I can't simplify it any further, so that is my answer. The next one says you earn x -$3 on Monday. I'm sorry, 5x -$3 on Monday and 7x + $5 on Tuesday. What were your total earnings? So since we want the total, we're just going to take those two things and we're going to add them together. So I'm taking my first day and my second day, and I'm adding them. So we are going to combine like terms. I don't have to distribute the plus sign since it's positive. You can distribute it, but everything just stays the same. So 5x + 7x is 12x. -3 + 5 is a +2, and I can't combine those, so that is my final answer. All right, we want to find the perimeter, and perimeter just means add up all the sides. So you could write it out in one long thing, or you could just kind of add it from here. I'm going to add it from the way it looks. So I have 1x plus 2x plus 1x. So that would be 4x's. And then I have one number plus 5 numbers, that's 6, minus 2 is 4. And it's a positive 4, so I put the plus sign there. That's the perimeter of the first figure. All right, for the second figure, I have 1x, 2x, and minus 1x. 1 minus 1, those cancel, and then we have 2x left. And then we have a minus 3, a minus 7, that's negative 10, and a positive 8, that would make a negative 2. And we can't go any further, so that is our perimeter there. Now, if you didn't know that, you could always type in negative 3 minus 7 plus 8 in your calculator, and it would tell you negative 2. All right, and then we want to find the difference. Remember, in math, difference means subtract. So we're going to take 4x plus 4, the first perimeter, and we're going to subtract off the second perimeter, which is 2x minus 2. Now, because we're subtracting, we got to make sure that we distribute that negative and change the sign of all of those in the back parentheses. So the 2x would become a negative 2x, and then the negative 2 would become a positive 2. And then I'm just going to bring this first stuff straight down. And now I'm going to combine like terms. 4x minus 2x is 2x. And 4 plus 2 is 6. And since it's a positive 6, I put a plus sign there. That is our final answer for the difference. Now we're skipping over to rules of exponents. Now when I do rules of exponents, I usually write it all the way out. If you can remember the shortcut, then by all means take the shortcut. But if I was going to write this first one all the way out, x to the 9th means that I have 9 x's. X times x times x, 9 times. And then x to the 4th means that I have 4 x's. And there's a multiplication sign right in the middle, so I'm going to put a multiplication sign there, and then I'm going to write out my 4 x's. And so if I just count up how many that is total, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that is 13 x's. That's my final answer. Now remember, there is a shortcut. If you can remember that when you multiply with the same base, you add your exponents, you could have just said the base stays the same, and then 9 plus 4 is 13. So let's try to use the shortcut on this next one. By all means, you could write down 2 5s and 4 5s and see how many that is. Or you could just add, you could say the base stays the same, so keep 5 the same, and then add 2 plus 4, which is 6. Now, because this is numbers, if they want you to simplify it further, you can simplify it. You can't simplify x to the 13th further because we don't know what it is, but we could go in our calculator and we could type in 5 raised to the 6th to get an answer for that. So sometimes on a test question, it might just want you to leave it as 5 to the 6th, and sometimes it might want you to give the whole answer. Okay, and then here we have y. So for this first one, I'm just going to write it all the way out. I have 8 y's on top. So 1, 2, 3, 4, 5, 6, 7, 8. And then on the bottom, I have 5 y's. So 1, 2, 3, 4, 5. And then whatever is the same on the top and bottom, you can cross out. And that leaves you with 3 y's on the top. So your answer would be y to the 3rd. Now the shortcut here is when you divide, you subtract. So you could have said, you keep the base the same, and then you subtract the exponents. So you could have gotten your answer that way as well. All right, so here, if we take our shortcut, the base stays the same, and then we subtract the exponents, and we get 3 to the 1st power. Now, since that's a number, it'll probably just simplify it and write it as 3. All right, and then down here, so in this one, the base or the thing holding up the exponent is x. So if we're taking our little shortcut here, the base stays the same, and then we add the exponents. But you can't keep this number 7 and 5 the same because those are not bases. Those are just numbers. So you're going to do 7 times 5, which is 35. So in this case, your answer is 35x to the 6th. And I'll tell you, that gets a little confusing because you might see a question that says like 7x squared times 7x squared. And up here, we keep stressing that you keep the base the same. So here, you do not multiply 5 times 5 to get 25 because 5 is the base. The base has to stay the same. But down here, 7 is not the base. It is not holding up the exponent. So you do have to multiply 7 times 7 to get 49. The base is x. The base stays the same, and then you add the exponents. So you got to be really careful. The base stays the same, but if it's just numbers that aren't part of the base, then you would multiply those. All right, so here's some scientific notation. There's 2 ways we can do this. The first way is to write it out in standard form. So since my exponent is 1, I'm just going to move my decimal 1 time. So if I wrote this in standard form, it would be 18. And then if I wrote this one in standard form, if I don't see the decimal, it's behind the 6. And then I want to move it 4 times to make it bigger because it's a positive exponent. So this number written out in standard form is really 60,000. And then I could multiply 18 times 60,000. And this would be my answer in standard form, 1,080,000. Yeah, okay. I feel like I'm saying that wrong. That's a weird number to pronounce. So that's my answer in standard form, but it's going to want your answer in scientific notation. So then you can go back and convert it to scientific notation. Now remember, in scientific notation, the decimal has to be after the first number that is not 0. And then you count how many times you move to get it there. So 1, 2, 3, 4, 5, 6. And then you can cut off all the extra zeros. So I would write 1.08 times 10 to the 6th power. That would be my final answer here. Now the other way to do that is you could just multiply the number times the number. So 1.8 times 6 to get 10.8. And then you could multiply, when you multiply with the same base, the base stays the same and you add the exponents. But I want you to be really careful about using this method because this is not the final answer because it's not in scientific notation unless the decimal is after the first number. So we would have to move the decimal 1 time, which is why the 5 becomes a 6. So you can solve it either way, all right? I think I'm going to try to solve this one with the shortcut method. So I'm going to multiply my number times my number. So 1.5 times 5 is 7.5. And then when I'm multiplying 10 to the negative 4th times 10 to the negative 5th, the base stays the same and we add the exponent. So I'm going to write this up here. Negative 4 plus negative 5 is negative 9. Now I'm going to double check and make sure my decimal is in the right spot. It has to be after the first number that's not 0. And in this case, it is in the right spot. So that is our answer. Just always double check that because up here it was not in the right spot. So we had to move it one place and change our exponent. All right, multiplying polynomials. For this first one, I'm just going to go ahead and distribute. Now remember, if you don't see a number there, that's a 1, so a negative 1x. So negative 1x times 5x, that's going to give me a negative 5, and there's 2 x's, so it becomes x squared. And then we have negative 1x times negative 4. Negative times a negative is a positive 4, and there's just 1x, so I would just write down 1x. Those are not like terms, so I can't simplify that any further. All right, I'm going to continue this review on the next video, so make sure you click on the next video to finish the review.